thinking about AI in healthcare and trying to think a little bit differently about them today. So today, there's no need to worry. We are not going to bombard you with new information. Today, the aim is to try and bring everything all together. So all of the things that we have talked about in the okay, we're good. In the last 6 weeks, we'll bring everything together into one coherent narrative, and then hopefully we have some time for some questions at the end, and then we're good to go. So just going to start off with, well, we've done this whole 6 weeks with the title of thinking critically about AI in healthcare. So if you remember way back in week one, that we started off with what is AI not and what AI is actually. So we're going to do the same thing. What does thinking critically mean? And what does it actually mean? And then the rest of the time we'll spend bringing all of the different parts that we've built up over the last 5, 6 weeks into a coherent narrative about how I think we can go from hype to hope. So starting off with thinking critically about AI. What is thinking critically not? See, this is where we're mirroring lecture one, where I said what AI is not. So thinking critically, I hope that you have got to the end of this lecture series that it's not about being negative about the potential of AI. So when I say thinking critically, I don't mean thinking critically in the sense of criticism or critiquing AI. I think that we should all be thinking very much about the potential of AI, but we shouldn't be getting hyped about it, is the real difference. Similarly, it's not being dismissive about specific uses of AI. It's not a case of saying we definitely should not do this or we definitely should not do that. And then linked to that is about being focused, is definitely not about being focused solely on the limitations of specific AI products. So it's not about saying, these are all of the things that are wrong with AI scribes, or these are all of the things that are wrong with using an LLM for medical research. That's useful types of research, but it's not necessarily what it means to think critically about AI. And I suppose the sort of meta point to all of that is that it's not about being anti-technology or resistant to change. I think sometimes that's the sort of party pooper image that ethicists like myself get, that we want to be anti-tech or being resistant to change. I once got called a Luddite on Twitter before Twitter was X and died. I'm not a Luddite. I'm very pro the potential that we can have from all of these types of technologies, and I hope everybody is, in the sense that we do in fact have an ethical duty to try and investigate all technologies that have the potential to save and improve lives. Where that potential exists, it's on us to actually explore them and to explore them properly and to think about what they could potentially do. And not just to say, oh, just because this is new, this is something that we should run away from. Similarly, it's not about being uncritical of humans or existing technologies. Again, I think sometimes that people say, oh, if we are talking about explainability, then people might come back and say, well, humans are not particularly explainable either. You can't always get somebody to tell you exactly what was in their thinking process, which is 100% true. And so it's not just about comparing AI to some form of unrealistic standard and thinking that humans are always good and technology or AI and automation is always bad. Similarly, though, within that, it's then also built in that we're not automatically thinking that they're better. And that they're better than things that are existing. And then this means naturally that it's not being too accepting of every critique or challenge about AI. It's very easy sometimes to build up straw men and to say this is absolutely what's wrong, this is the flaw, this is not reflecting reality and all of that type of stuff, which is all valid, but we shouldn't just take at face value if someone comes along and critiques a specific type of AI. And so then that raises the question, what is thinking critically actually? So if it's not all of those things, I hope what we have learned over the last 6 weeks is that thinking critically is about being aware that AI is a systems technology. So it's about being aware that AI doesn't operate in just at a product level. It's operating at the very nature of what does it mean to deliver healthcare itself. What does that look like? Who are we designing it for? What are the changes that we should be aware of? And what are the opportunities that we might be missing if we're not paying attention to the fact that it's a systems technology? And then from that, that means being cognizant of complexity. We have to be aware of the fact that AI is a systems technology and it's also embedded in systems. So to use the sort of social science word, we're talking about socio-technical complexity. So how does it interact with all of the other parts of healthcare? How does it interact with humans, be they clinicians or be they administrators or be they patients, be they average members of the public? And then complexity in terms of all of the infrastructure that is required in order to support AI and what that looks like. So we need to be sort of fairly aware of the fact that it's not just a plug and play system. It's not just a case, as I think I'm sure you've all got bored of me saying now, that it's not just a case of like taking something that was, say, for example, an analog blood pressure cuff and turning it into a predictive blood pressure. It is much more, it's much bigger than that. And then it's really about being willing to question assumptions. So sometimes I think people ask me, well, what can I do? How can I challenge the, AI? What are the things that I'm supposed to be thinking about? And that can feel a bit overwhelming. Sometimes if you go and look at some of these checklists that exist, there is a guide, for example, by CHAI, which is the Coalition for Health AI. Their guide to responsible AI is more than 200 pages long. And I think people can sometimes feel reasonably overwhelmed by that. And then the easiest thing I can think of to say then is just ask really awkward questions. I'm sure everybody has at some point interacted with a toddler. Why? That's the logic. So why are we building this? Why was this the right solution? Why was this model chosen over that model? Why did we think that this problem was the appropriate problem to be solved by AI? Why was it this person's decision and not that person's decision? Why were patients not consulted? Why were clinicians not involved? Those are the kinds of why things I'm talking about when we're talking about questioning assumptions. And then linked to that then is being willing to ask what we want to achieve, not just what we can build. And that means not just thinking about the now, it's thinking about the possible and not just the plausible. So if we can imagine it, we can sort of bring it into being. So right now, and we'll talk about this again, there's a lot of this is what's technically possible right now. So therefore, that's what we should build. And then there can sometimes be with that a little bit of a resistance to thinking about what's possible if we're not doing just what we already currently do. But it's much more about, and this is the thing with regards to it being a systems technology, what is it that we want to achieve with an AI enabled or an AI sort of enhanced care system? What is it that we want to achieve? And then that means being aware of power dynamics. So that's linked to this sort of irritating toddler asking why, and questioning assumptions. It's about whose decision was it? So we really need to think about who's underpinning all of this, who's building these technologies, who's funding these technologies, what are the sort of therefore assumptions that are built into them that come from that dynamic. And then also, what are the impacts in terms of power and who has the right and the ability to question and to challenge, and who is being sort of pushed out of the system as a consequence. And with that comes being mindful of the risks and the harms and how they can be mitigated. So it's not about running away from them. It's not about saying that this is so risky, we shouldn't even touch it with a barge pole. It's much more about saying, okay, we're going to be really, really, really honest that we know that these things exist, and that is going to give us the opportunity to plan how we mitigate them. So fundamentally, what thinking critically about AI means, especially in the context of healthcare, is the bookends of this list. So thinking critically about AI is being aware that AI is a systems technology and therefore being focused on design of AI as a systems technology and thinking about systems design. So now we have that framework in our heads. We have this idea of what it actually means to think about critically about AI, to question all of the assumptions, and to think about it being a systems level technology and therefore to think about systems design. How have we started to build up that logic over the last 6 weeks, and what does that look like? So starting off with this definition, when we came from what is AI is not, and this is what AI is. So AI, a new form of agency that separates the ability to problem solve from the need to be intelligent, and it operates at the systems level. It is not just some form of automation of intelligence in the way that we think about intelligence. It's not that sort of higher level cognizant contextual understanding, but it does allow us to abstract away the need to be intelligent from the need to be able to, the ability to problem solve. And with that, that means we get the freedom and the ability to play. It allows us to think about absolutely everything in a different way. It allows us to stop thinking this is where we've always done things, and therefore this is the way we should always continue to do things. Think about how we had these massive disruptions in the way that we have had in the past. Think about what happened when the car came along. Think about what happened when the mobile phone came along. Think about what happened when the internet arrived. That is the sort of level of disruption that I'm talking about. So when we have an injection that changes almost everything and gives us the freedom to think, well, okay, actually, we could think about this differently. I no longer need to make sure that everybody is within 10 minutes walking distance of a payphone, for example. This now means I can redesign my ways and the ways that cities work. The same logic applies. Just because I now no longer need to have a clinician and a clinical knowledge located in a specific place with the patient at that specific location, what does this freedom allow me to do? And where are the edges of knowledge that we have relied on when we have assumed that those were hard edges that could never be blurred and could never be broken through? Where might they be and how might I be able to play with them? So this sort of a logic of being able to play and readapt the system and rethink about it is basically about thinking about what are the things that are separated as a consequence of this disruptive technology, and what are the things that are joined together, and what are the consequences of this, and consequences being both positive and negative. So the examples that we thought through here is you can separate symptoms and diagnosis. That immediately means that we unlock an enormous amount of potential in terms of things like rare diseases, and in terms of understanding and broadening the diseases. Now, this is something that is a really classic example of where you can think about things becoming coherent. You probably see a lot of the time in the press when things like, I don't know, ADHD is a big one, or autism is another big one that's always in the press, at least in the UK all the time, where people get up on that sort of really concerned that they think the rate of diagnosis is going up, and that therefore means that the incidence rate is going up. Well, actually, oftentimes it doesn't. It means that the diagnostic criteria has changed. They've broadened. We've developed a better understanding of what it actually means underneath the hood in order to give somebody that diagnosis. And that can be a really, really positive thing. So if we've separated symptoms from diagnoses, what does that mean in terms of our ability to treat people? But on the reverse of that, we then have the sort of negative side of things, is that that means that we are also joining together patients and their data in a much, much more joined up way. So we're not talking about necessarily treating the patient anymore, as in treating a kinesthetic person who exists in 3D space. We're talking about treating their data profile. And we've spoken a lot about that being a data shadow rather than it being a data representative. What is lost in the granularity in terms of experience, in terms of contextual understanding, and what therefore might be the consequences of that. So this is what really shows you right at that beginning point in time, when we think about what AI really genuinely is in terms of it being a systems technology, and therefore how do we start breaking down the risks versus the benefits and what we think about designing them. You can see even from this very early stage that that's what allows you to do that. And so then if AI is a systems technology, what do we actually mean in terms of systems design? And then if I'm saying that thinking critically about AI is primarily thinking about systems design, we have to remember that form follows function. That's the sort of TLDR, or as I said, TLDL, too long, didn't listen. This is the main key takeaway. So we need to design the structure of the AI-enabled and AI-enhanced healthcare system based on what it needs to accomplish, not just based on what already exists or what's convenient. So what outcomes do we want to achieve? Then we need to identify the required capabilities or the required requirements. We need to map those capabilities to components. So if a system needs to be able to pass data from here to here, what does that mean in practical terms? That gives us the ability to then design the system architecture. That then gives us the ability to define new roles and workflows as to what does that look like in practice. That gives us the ability to identify required changes. So if we have new roles and new workflows, that might mean that we need new education and we need to give people new skills. And then we need to plan implementation sequence. So this is not just something that we're saying, okay, day one, just go forth and use it. It might mean that we need to do things in a staged sense because maybe we need to do curation of the data first. Maybe we need to think actually that we need to redesign the electronic health record because this particular variable isn't currently recorded. That might mean that we need to ask, why is that variable not recorded, and what is the problem with that? Is it a social problem? Is it a technical problem? And then very clearly we want to define the success metrics, and those ideally should be linked to defined desired outcomes. And so what I have said in the past, I don't think I've said it in this series, but it's another thing that you can sort of keep as a catchy takeaway phrase. Don't write ethics into the business case and code them out by the time you have deployed. That's really what this means. So if you're defining the outcome, this is what we want to achieve with the consequence of using this AI in this healthcare system. Therefore, how do we monitor that, and what do we do in terms of actually designing and saying, yes, we've achieved what we want to achieve. This means that we are successful, and we can now keep going forth. So what currently exists in this space? What is the current idea that's sitting behind all of this? What's the current function that we are designing for? And this is where we really start getting into the thinking critically. So this is the one that exists. This is a quote that comes directly from NHS Fit for the Future in 2025. But there are multiple versions of this that exist across the globe. There are parallels in everywhere from the US through to China, through to South Korea. If anybody wants their map, we did publish a paper on it. But basically, we stand at the cusp of an AI era where data and AI will fundamentally transform healthcare, and where genomics and predictive analytics will deliver an increasingly sophisticated understanding of individual health risk, powering a totally new approach to prevention. And then we sort of start thinking about, okay, so where is that coming from? If this is this idea that that's what we want to achieve with AI, is this sort of predictive, constant prediction and this personalized experience, what does that actually mean? And how did that get there? Well, that means we need to look at the full capabilities and the full breakdown of AI, and then you can start seeing where they fall into it. So if we will remember, we talked about AI being an umbrella technology. So it's not just one thing. You've got everything from analytical AI all the way up to generative AI, symbolic AI being your most simple version there, that being the thing that is my favorite, called GoFi, good old-fashioned AI. So if we sort of start with analytical AI, that's about identifying people and putting them into subgroups. It's classification, really. And then that means that you're going to be able to do quite exceptional pattern recognition and then discover who is disparity. So where are the inequalities? From a cost reduction perspective, you can look at how you identify what are the costs. So it's bracketing things and saying, okay, this is associated with X. From a clinician's experience perspective, it can surface new insights that might not necessarily be there. And from a health equity perspective, because we have identified these disparities, we can start discovering hidden biases and understanding where they are. Predictive AI is the thing that most obviously comes through, but this is where we're talking about taking a past pattern and saying, given that this happened in the past, what does this mean in the future? So if we were talking about here, analytical AI has maybe put people into buckets. This is where I sometimes said that personalized medicine is much more like targeted advertising. We put people into different buckets: category A, category B, category C, category D. That's what the analytical AI has done. Then we might use predictive AI to say, in the past, we had patients that exist in category A. These are the outcomes that they previously experienced. Therefore, if we have a new patient that falls into category A, this is probably what's going to happen to them. And then we have decision-making AI. So this is your sort of optimization pipeline. This is where we normally try and talk about having something that you talk about there being a target. So if we are trying to achieve this, what is the best way of achieving that? And this, in this instance, might mean in terms of personalized care pathways. So we're trying to optimize to the idea that we have someone who has falls into category A, that means they're probably going to have category B outcomes. This means that they should go down pathway C, because pathway C for patients in category A has always led to the best types of outcomes. And then if you were not doing anything more complicated than that, what you might see is that that's then encoded in an evidence-based protocol. So this is really about trying to explain the fact, and I think I made this point in one of the lectures as well, that we're always having this trade-off between complexity and readiness. So those three things that I've just described there are quite complex. They require fairly high amount of system readiness, both infrastructurally and also sociotechnically in terms of the requirements that sit around it in terms of governance. It might be that your organization wants to be able to do this, but doesn't quite have the system readiness in order to actually make that possible. So you can default to something that is simpler, simpler being symbolic AI, which is basically an evidence-based protocol that's made automated. So it might be that all of this information, instead of happening in real time, is just encoded into something like a pop-up, a very, very simple if this, then that. So if I have a patient that looks like this, I should tell them how to do this. That's essentially encoding all of that knowledge that we've learned in a simpler and more formidable way, formalized way. And then we will have generative AI on the end, might be enabling patient engagement. So we've got a person who was in this category who knows that this is their prediction that's going to happen to them, who's now been pushed down this pathway. How do we make it so that they are able to interact and understand what are the next steps in that pathway, and who do we need to give them questions, and how do we allow them to sort of ask those questions? That might mean using something like a generative AI chatbot, or what we sometimes call companions, that allow people to interact, and they might tell them, oh, you need to go to your appointment tomorrow. And then if they want to ask, oh, what questions should I be discussing with my clinician? So you start seeing how the different types of categories of AI build up that logic that sits within that rhetoric, that what we're trying to do is enable sort of P4 medicine, and then that achieve this quintuple aim. So basically make medicine that is more predictive, more personalized, more participatory, and more preventative, and therefore improve the patient experience, improve the population's health, reduce cost, increase the clinician experience, and importantly, increase health equity. So what is understanding? What is actually sitting underneath that logic? If we ignore the fact that there are all of these different types of things, what is really running underneath this, and therefore this what enables us to start questioning the assumptions that sit underneath it? Well, what it's really saying is that AI is going to integrate a diverse amount of data to generate predictions of individual health risk and system level demand. So taking everything from your patient records to imaging to things that might come from your wearables or your shopping records or anything like that, using that to predict and provide individuals with personalized knowledge about their health, and provide systems with precise analytics about where to allocate resources. So you as a healthcare system have more patients who fall into category C than you have in patients who fall into category A. Those patients typically require pathway B. That means you should allocate the resources that are attached to pathway B. And from a patient perspective, that is saying you are at an exponential increased risk of developing type 2 diabetes. You should start doing these types of activities in order to reduce your relative risk of type 2 diabetes. That is what enables individuals to take more proactive care of their health, and this prevent disease before it occurs. And it helps systems reduce waste, optimize flow, and ensure that you're delivering the right care to the right patient at the right time. And it's this combination that ultimately aims to achieve that quintuple aim of improved everything, from patient experience all the way up to equity. And so once you have the logic that sits underneath the current function, that allows you to start breaking down the assumptions, and that's what allows you to start thinking. Because then we start recognizing, okay, so all of that I've just said is only talking about those first three components. It's talking about the data. So what is required? What are the ingredients that I need to give to my algorithm, which is the recipe that then I go into giving a model, and that allows me to start playing around with it and actually interacting with it. So the input is what determines what AI learns from. The learning method then finds the patterns in the data. The model is the finished product that applies what was learned to complete tasks. That sort of assumption, understanding that we just talked about, doesn't ever really go beyond that. But what we have then thinking in terms of the recognizing complexity, remember that being one of the things that thinking critically means, is that actually the full pipeline also includes these three components. So it also includes implementation, so embedding the system in a clinical system that has to be used in real life, then going through to the action that's taken as a result of that model's input. So what do people do as a consequence of that input having been given to them? And then what's the outcome? And that outcome being the result of the model plus the implementation plus the action. And a lot of the time people fall down here. They just think because the model works, I therefore don't need to think about this. And that's where things start to fall down, which was then lead you on to start thinking about what are the translational stages. So how do you translate between the different pipelines, and all of these different types of things. So if you're translating, you're going from data to algorithm. That means turning clinical reality into a computational output. And the core question that we should be asking there is, does the data represent what they think it does? Like, is the actual data representing the full complexity of the problem that we are trying to deal with? And then the next translation is from algorithm to model. So this is when methods become performance claims. So if we start saying, oh, this algorithm is 90% accurate, that then means we can improve patient outcomes by 90%. That's where we should start having alarm bells going off in our heads, because we actually want to think about, does the model perform credibly across contexts? And what happens when it's given different patients? What happens when it's implemented in a different hospital? If it's something that's deployed directly to the patient, has there been assumptions made about what quality of phone, for example, that patient has? I think the example I've used, and a really good one to get your head around, is skin recognition algorithms. There are hundreds of them now, that I'm not going to name ones because then I get accused and I get threatened with being sued. But there are many that you can download on the App Store that aim to say that what they can do is you take a picture of a rash or a mole or something on your phone, and it's going to tell you what the level of risk that is something that is malignant is. And the problem often is that that model has been tested and trained inside sort of perfect grade images. And then you deploy it inside somebody's sort of iPhone 9, then on a photo that they took in their dark kitchen, on skin that the algorithm was never seen, and you expect the model to perform at the same level. And that is not really always thought through. And that's what I mean in terms of the model becoming a clinical product. So once you have this next translational stage, is can the model be safely integrated into the workflow? The one I've just given you, that was a workflow, that was a patient-specific workflow, but there's also workflows that exist inside a clinical consultation. So that starts like, okay, does the algorithm need to have access to a patient's live electronic health record? What level of granularity? Where is that record stored? When is the particular variables input into it? At what point does the model fire? So is it something that the clinician has to actively go and ask, or is it something that's going to like push notify? At what point does it push notify? How does that impact the cognitive workflow that's happening inside a clinician's brain? How does the outcome of that get put into the care pathway? All of those are the types of questions that should be thinking about in terms of workflows. And again, this again is a really obvious one to look at in terms of image recognition. If I put an image recognition machine into a hospital that can never turn off, it's never going to sleep, it's recognizing mammograms every 5 seconds, that doesn't necessarily mean that I have the capacity to treat all of the people I have now flagged as risk. So what does that mean, and how do I cope with that as a healthcare system? Which is then this thing about T3, so your implementation at translational 3, which is where we go from implementation to action. So how does that information become a change decision? So can clinicians and patients act accordingly? So that's that example that I've just given you. If you have embedded the system into that workflow, does it actually meaningfully change anything? So is there any point in predicting something that nobody can do anything about? Or is there any point in predicting something that actually is going to cause psychological harm because there is nothing that we can do about it? Or is there any point predicting that this is the most appropriate drug for this particular patient if it's not available in the system? So those are the types of things that you want to start thinking about. And then ultimately, we want to talk about actions into outcomes. What happens as a consequence of that change decision, and how has it become a measurable benefit? So has it turned into something that interventions improved outcomes for the population, or has it only improved outcomes for a certain group of people, or has it not actually improved outcomes at all? Because maybe there is a breakdown somewhere along here that means even though the data represents the problem very well, once it's got to this stage, that doesn't actually translate into any improvement in outcomes. And the thing that's really important to sort of note is, and that was my point just previously, those assumptions start falling down because the rhetoric relies very much on T0 to T1. And so the sort of thinking critically point here is at each translation point, we should be asking what has to go right, what typically goes wrong, and what are the infrastructure, governance, and capacity that are required at each of those stages in order to make sure that that right thing happens and we avoid the wrong thing. And that's what then gives you the requirements for systems capable of successful translation. So capable of crossing that algorithm graveyard problem where we talked about the fact that less than 2% of models ever make it outside of a research environment. And these are the sort of key failures that need to be avoided. So at that first stage, things fail when we treat data as neutral, rather than a contested, partial, or politically shaped representation of clinical reality. There is always a reason as to why one particular variable was recorded in one particular format. That next stage fails when we treat validation as a technical exercise rather than a value-laden choice about what counts as success and for whom. So this was the point about just get away from this idea that you have a great AUC. I really am so proud of you. Well done. You have a really accurate algorithm. Clap on the back. Please go to the pub and have a pint. But that doesn't necessarily mean that I'm now going to say that that's validated and works for a clinical system. Actually, what I care about is what happens once that system has gone live. And so that means evaluation, not just technical validation. The next stage, we're going to fail when we treat implementation as a deployment problem rather than a workflow problem. So that's when we think about it as something that's just plug and play. Like I said, it's just something that is now available. You now have Microsoft Word on your laptop. Cool. No, it's about how do you know that you need to go and open Microsoft Word and how you type into it and who does you then send the document to. That's that kind of thing about it being workflow. Next stage fails when we treat action as a matter of individual behavior rather than something that's about capacity and design. So action is something that happens in the round. So that's everything from how does the information presented either to the clinician or to the patient influence the extent to which they are able to make a change, and then everything that sits alongside that decision that they have made in terms of a change that makes it possible to actually act on that decision. And then the last one is things fail when we treat outcomes as model metrics rather than improvements in population health. So just because we can now predict very, very well that this particular type of person is going to be hospitalized next week does not make any difference into population health. And I showed you the metrics there. I showed you the from our paper in terms of from promising applications to perilous algorithms, where we showed that almost everything falls down once it hits the real world. And so once you understand that, once you've understood those translational failures, and you've understood where they come from, you can start thinking about what the system requirements that are actually needed in order to avoid those things. And that was the ones at the list I gave you. And this is what really, when people are talking about systems design, and especially talking about AI governance, it means covering this entire set of requirements. So everything from epistemic certainty, how do we make sure that the signal is credible enough to act on, all the way up to meaningful accountability. So how do we make sure that somebody is responsible for correction and redress? That means we need to understand the entire pathway, the entire development pipeline, so that we know if an error has occurred, where's the source, and therefore whose head is on the chopping block and how do we go back and fix it. Things in the middle are about thinking about what are the trade-offs and are they explicit and are they contestable. So, there are trade-offs, for example, that are sometimes very obvious, which might be between accuracy versus explainability. When we're using a more complex model, we don't necessarily understand what's happening. This is like if you're talking about statistics, parametric models are more explainable and understanding than non-parametric models, but non-parametric models are better at modeling complexity and feedback loops and things that are non-linear, which is most of the time the thing that we care about. But we should be obvious that those trade-offs have been made, but some of those trade-offs are more value laden. So they might be, for example, we've encoded more quantitative types of data, but that means that we are not including things like what patient experience matters, or what patient's preferences are. And this is where the autonomy comes in. So we want to make sure that clinicians can still override. They're still the people who are in the driving seat. They are protected and encouraged to sort of maintain that sniff test. Anybody who's clinical will know that sometimes somebody just walks in to your clinic and you know something's wrong. This looks off. How do you maintain that so that people don't fall foul of what's called automation bias, which is this idea that the computer is always right? And this is similarly on the other side means that patients should be able to disagree. They should be able to say, I don't think that's right. That doesn't actually reflect my experience. It doesn't reflect my patients, my sort of preferences. And then that means that we have to think about the normative cascade. So if we have these ideas that sort of sit in that ethics level, which is thinking about what it is that we actually want to achieve and that difference between could versus should, that means that then it needs to translate it into law. That law then constrains what healthcare organizations are able to do. And then that's what protects healthcare users and beneficiaries. And currently, things are quite broken in this normative cascade. The governance pipeline of healthcare AI is being stretched in every single direction. It's being stretched from a medical device law, it's being stretched from the perspective of discrimination law, it's being stretched from the perspective of consumer protection. So we have each of these steps and start thinking about where they are broken. Now, the thing that means, because this is recursive, this also means that things that happen at this end, so healthcare's users and beneficiaries, can also influence what is considered ethical at a systems level, which can therefore also exist the law. So things don't just come from top down, they also come from bottom up, which means that we should be listening to people. If you start getting a signal that you have deployed an AI scribe in your hospital or your GP practice or your primary care practice, and patients are telling you that they no longer feel comfortable discussing certain types of things when they are in a clinical consultation because there is an AI scribe that's sending their information back to who knows where, that's a signal that that's not ethically justifiable. And even though it's not prevented by the law and the law has not yet told healthcare organizations that they shouldn't do it, it's something that you should act on. And that was this point about thinking about things through in integration, not in isolation. So we very often get stuck on this thing in terms of technical feasibility, but it's about joining up all of these different aspects. So everything from technical feasibility influences social acceptability, influences ethical justifiability, influences legally compliant. That's that normative cascade, but they also go the other way. So things that's ethically justifiable should also influence what is technically feasible. We shouldn't be building stuff just because we can. We should be thinking about what we should build, even if it is perfectly legal. Because remember what I said in terms of the law is the floor and not the ceiling. The law is telling you the absolute minimum. It's telling you the rules of the game. It's not telling you how to win. And then that leads you to start thinking, okay, so if I want to avoid those ethical risks and I want to make sure things are all joined up, what are the things that I want to talk about? And this is where that requirements things come in. So your sort of ethical risks are epistemic, they're normative, and they're related to accountability. So they're related to the types of evidence that's related to the data that's going in. They're related to the normative, which is about what happens as a result of this having been put into the system, which is that implementation and outcome bit. And then they're related to the accountability, which is that thing about responsibility and accountability, and specifically, how do we redress things that have gone wrong? So your sort of epistemic risks are things from inconclusive evidence. So that is basically if we're using something that's wrong, we're trying to posit that there's an existence of a causal relationship. This is where things fall down an enormous amount of time in healthcare AI. You're confusing prediction, which is essentially pattern recognition, with it being causal. Just because there's a pattern there, it might be correlation, it might not be causal. And if we confuse those two things, the action that is recommended is often wrong. So the example that's given by very famous causal researchers is smoking. One of the biggest signals of smoking is that somebody has yellow fingers. If you treat the yellow fingers as being the thing that's causal, the action that you're going to recommend is that you should wash your hands. And that's not actually what is happening. And then there's the misguided things. The algorithm outcomes are only as reliable and therefore only as neutral as the data that they're based on. If we've collected the wrong quality of evidence, we've collected the wrong variables, we're going to predict and tell people to act on something that's wrong. And then the big thing is that we don't necessarily know where that stuff has come from. So this is about provenance as much as it is about anything else. So where was the data set come from? Why was it chosen? Why was it the one that was correct? How was it passed from place A to place B to the developer to and so forth and so on? Even in just the NHS, just in England, so only in one tiny island across the sea that's responsible for regulating the price of tea, if you want to use the Hamilton lyrics, that is in that specific location only. Your electronic health records from your GPs are going up to anywhere between 450 different intermediaries, and then those 450 intermediaries are sending that data onwards. We have no way of tracing back that provenance. And now that is a really big problem when we think about the fact that things might be wrong. Your normative risks then are the things that happen as a result. So who is benefiting and who is not, that is only typically obvious at a group level. It's not always obvious at an individual level. And then there are things in terms of transformative effects, which is like profiling and reconceptualizing reality in unexpected ways. So if we are predicting that one particular group of patients is always at risk of this particular type of disease, that might start saying that actually there's stigma attached to that patient group and they're less deserving of care. And then this was just to remind you that those risks arise at multiple levels. So even though we tend to focus on this individual level, we tend to think about what happens if the algorithm is misdiagnosed as this one patient. Actually, everything scales up from the individual level all the way from the interpersonal to the group, to the institutional, to the sectoral, and to the societal. And when we are talking about it being a systems level technology, it's the societal level that we ultimately care about. And things flow backwards from there. So we should be designing for the societal level, and then that should make sure that each of these things work so that the individual level is also protected because we've protected at the societal level. It doesn't go upwards. Just because we think something works at an individual for a certain subset of individuals does not mean that it's going to lead to desirable societal outcomes. And then this leads to the point, therefore, around what really hinges on things. So if we've just broken down the current rhetoric that underpins the current function that sits underneath AI, all of the logic, all of the things, that then makes us ask, is this what we actually want from AI? Is what we really want this sort of P4 predictive medicine system? If we know that things are currently not really working, nothing is effectively scaling, and things at work, which means, are we trying to develop faster horses when what we really want is cars? Sorry, excuse me. And that is when we can start thinking about flawed assumptions. So many of what I've just described relies on this idea, if you go back and think through what I showed you in terms of that underpinning logic, that what we need to do is tell people a specific thing at a specific moment in time. The reason that this person doesn't act on the fact that they are at risk of type 2 diabetes is because they don't know and they haven't been told what to do. Now that, I'm afraid, is a fundamental misunderstanding of humans. I don't know if any of you have ever met a human and told them that they should do something and then been hopefully not surprised when they don't do it. That is basically what is really wrong. There is several assumptions that are flawed there. Just giving somebody a piece of advice does not mean it turns into knowledge. Information does not translate into action. It does not necessarily equal efficiency. So just giving people more information does not necessarily enable them to make better decisions. Information does not necessarily equal autonomy, and informed individuals do not equal a healthy population. Which is why we currently have a lot of false hope that's underpinning this hype of this type of logic. So the optimizing individual health through P4 medicine produces a sort of compounding error. So it's treating prediction as causal inference. Like I said, it's treating this idea that if I can determine who is at risk at what point, that's actually causal in terms of that's what's causing the disease. And therefore, if I intervene at that individual level, I'm going to get a better outcome. It targets individuals rather than structures. So we're telling individuals how to change their behavior, whether that be individual clinicians, or it be individual patients, or it be individual members of the public. Now, most of the time, that action is constrained by the environment in which they live. And most of the time, the cause is actually coming from a much higher level upstream. It's not coming from downstream. It's not necessarily coming from what a person cooks for dinner. It's coming from whether or not they were taught about nutrition, and then whether or not they have access to healthy food, and whether or not they are able to cook it because they are in a house that provides appropriate cooking equipment. Then it also mistakes information for intervention. So that's that point I said. It's about structural, and it's optimizing an ideal that's not necessarily normatively appealing. So the way in which a lot of these things operationalize the idea of health is this what we call the biostatistical idea. So this is basically this idea that you're healthy if you have no presence of disease or no presence of injury. That's not really how people experience health. People tend to experience health as it being something that enables them to live a good life. It's enabling them to live a life that they want. It's also very exclusionary. If we have people who are in a different body than that falls within inside this norm, they're not necessarily included. And that's what makes this sometimes unachievable and indeed undesirable. And thus, we have this issues where AI is transforming healthcare by identifying patterns that humans miss, which is great, predicting risk before disease manifests, which is also great. All of these things are great. But what is currently resulting right now is that there are thousands of AI models deployed in healthcare. Many of them achieve acceptable performance in validation studies, but few are deployed in routine clinical practice, and even fewer with evidence of improved patient outcomes. Now, this is the really big one. They're all falling down. And at a systems level, which is the thing that I was telling you that we should really focus on in terms of societal level things, these are the risks that are consequently having that we should be paying attention to. So it's treating people as their data selves rather than their whole persons. It's expanding this idea that you're permanently pre-sick. You should always be doing something that can make your health better. You should be monitoring every aspect of your everyday life. From a systems level, it's sort of locking things into this idea that everything is coming from individual behaviors and everything's coming from some form of biological signal. And therefore, everything is essentially medical, whereas actually a lot of stuff is social. So what I'm trying to say is that there's a paradox inherent in this idea. Often these ideas and these systems are deployed because they are given this sort of logic of move care from the clinic to the community. Because they predict everything in a sort of biomedical sense, they are actually pushing people back into the clinic rather than necessarily allowing them to increase in the community. And the sort of net effect is that people are more paternalistically controlled by these types of systems. And so then the question is, why is this happening? And am I telling you that this is all bad and everything's terrible? Well, hopefully this is why I gave you that reminder right at the beginning, and that thinking critically is not about thinking negatively. No, of course, there is an enormous amount of benefit that can come from using precision medicine, from doing prediction at an individual level. But what it highlights is that there is a difference between an information want and an information need. An information want is when we're assuming that just because we're predicting something, it's actually useful. An information need is when we know that providing this particular piece of information at this particular point in time leads to this particular outcome, and we can evidence that that happens. Now, the conflation is happening because a large, very, very, very large amount of these products are being built by people who do not have understanding of the complexity of the healthcare system. This is not a negative criticism of them, it's just a statement of fact. Just very often these things and these tools are being built by people who are phenomenally clever technically, and they are incredibly good at understanding what data can be done and what algorithms should be built, but not necessarily understanding about everything that goes under the hood, how healthcare is experienced, how it is delivered, and how it is working. And this process is epistemic capture. Basically, the technologists have become the people who have decided what questions we should be asking, have decided what counts as a problem, have been deciding what counts as evidence and what counts as success. So the whole point of me doing what I do, and also hopefully what you all feel capable of now doing, is rebalancing this. So we shouldn't just be thinking that the only people who get to determine what is built and what is done with AI is the people who build an AI. It's also all of the people who live and breathe and experience healthcare, which is basically everyone. So we should have as much input from those people, should be the people who are really determining the function, which should then determine the form, not just the people who go out and say this is what's capable and this is what we should be building. So how do we negate these negative assumptions that I've just discussed? And what is the real sort of fixing thing? Where does thinking critically through all of these things think through? So we should think things through in terms of theory-informed function. So this is thinking through what actually causes health, what causes bad health, what causes things to go wrong, which comes from healthcare theory and population theory. We'd be allowing for contextual flexibility. So we should understand that humans are not robots, and that telling them to behave like robots is probably not going to work. And it should be clearly based on needs, not just on this idea that the data is there and I can build a model and aren't I cool. The luck of this is that we can turn everything that's currently hypey into hope by flipping the narrative around. So if we are thinking about prediction and that not being causal, we can switch from only predicting to thinking about causes. So just because I can predict that this person is unwell, actually, what is causing that person to become unwell, which actually means what's causing that particular group of people to be more unwell than that particular group of people. Instead of targeting individual causes of cases, we can start targeting the structural causes of incidents. So instead of how do I think this particular person is behaving and what's that impacting their behavior, how is this particular system, this particular city, this particular location driving up the causes of incidents? So why has town A got a higher rate of type 2 diabetes than town B, and what do I do about it? Instead of intervening at the sort of informational personal level, we intervene at the structural level. So we start understanding, if I pull this lever as the system, what can I actually start doing? And instead of thinking about policing people to this sort of biostatistical idea or this norm of this is how much you should weigh, this is how much you should exercise, this is how many steps you should take, this is start thinking about what is it in terms of what these people are able to achieve. And that means that we should also be using AI to understand how do we enable people who are already unwell, who already have a diminished capability, how do we use AI to help them also flourish? So instead of sort of penalizing and trying to say that it's therefore your fault if you become unwell, we're saying, okay, maybe the system has made you sick. How do we now design the system so that even though you have become sick, you are able to still live the life that you want? And so this is my last and final slide, and this is where we end, is that you don't just improve population health by empowering individuals and organizations to fight downstream. Once you have a signal that's coming from a downstream level that this particular incident, this particular person is at risk and this is the right drug, that might be a solution to the problem, but you improve population health by changing the conditions upstream. By benefiting to individuals are the consequences of system level intervention, and they are not the target of it. So don't thinking about just individual people or organizations. AI is a systems level technology. Therefore, we should focus on using AI to enable a mechanism that operates at the same level. And that, my folks, is the end of how you're thinking critically about AI in healthcare. And hopefully that was made clear how this whole narrative over the last 6 weeks has been building. You can always go back to the individual lectures that break down any of those arguments in more detail. And I just look to see if there are some questions. I think there is one, and other